Hey everybody, so we're going to be talking about symmetry today. Now, you guys are used to that, and symmetry exists if there is a rigid motion that maps the figure onto itself. Now, there are three different types of symmetry. The first one we're going to be talking about is line symmetry. And I'm going to be using a different color for each of these. Now, line symmetry, I want you to think of a mirror image. So you can fold it in half, either from the sides or from the top down. And it's pretty much being reflected in a line. So I can draw a dotted line in between. I can fold it in between, and I would have that same shape. I could flip it across that line. Now I could also do it this way where it's from top to bottom, and I'm flipping it over and that works. Pretty much this is applying our different transformations and to see how that symmetry is. So for example, with point symmetry, I just want you to see that it looks the same upside down. You can turn your paper upside down, looking at that center point, and see if it's the exact same shape. If it is the exact same shape, upside down, that means 180 degrees about that center point, it is the same shape, and it has point symmetry. And actually, I told you guys I was going to use different colors, so let me go ahead and change my colors. All right, and actually let's do blue for this. We can use yellow for our sun here. Now, the yellow one, the rotational symmetry, I want you to think of a pinwheel. Pretty much it's that center point that we can rotate it, and no matter how many times we rotate it, less than 360, we will end up on the same spot. So I can rotate it here, and I'll have the same exact sun. I can do it here, and here, and here, and here, and here. So our job is going to be figuring out which of these symmetries apply to the different shapes. And that's your assignment. So let's look through this. We've got line, point, rotational, or none. And I'm going to be keeping with my different colors. And I've got line right here. I can fold it from the side. I can flip it over there. I can flip it upside down. And it would be the same exact shape. So I can make sure and check off that it does have line symmetry. So we can actually look at these different shapes right here and see if we can either flip them from the middle or from the center. So that triangle, the star, and that hourglass looking one is those are the only ones that are going to have line symmetry. The R and the recycle one don't really work. So now let's go ahead and look at point symmetry. So this one, if I flip this hexagon over from that center, the 180 degrees, then it'll work. Now I want you to look at this triangle from up and bottom. Flip your paper around and you can see that it's not the same, so it does not have point symmetry. The same is for the star and the R and even the recycling sign. Once you're looking at it upside down, it does not have point symmetry. It's not the same figure that you're looking at. All right, and let me go ahead and put my X's there so we know that we're keeping track of all of these, that they don't have line symmetry or point symmetry. That way we can check off the none box if we need it. All right, now we're going to work with that rotational symmetry. Same point center point, and you're going to be rotating it less than 360 to get back to the shape. This hexagon does have rotational symmetry, and anything that has point symmetry, because you're rotating 180 degrees, which is less than 360, also has rotational symmetry. So I can check those two off. But just because you have rotational symmetry does not mean that you do not have point symmetry, all right? And the reverse and everything is also true as well. So for example, the star, I can rotate it. Even though it doesn't have point symmetry, it still has rotational symmetry. And the same is true of this recycling sign. The other two, I can only rotate it 360 degrees to get back to where it originally was. And actually that triangle would also have rotational symmetry. All right, next up, this is some extra stuff that we're going to talk about. And this is the order of symmetry. This is the number of times a figure maps onto itself as it rotates from 0 to 360 degrees. Now, that can be determined, okay? That can help you determine the magnitude of symmetry, which is the angle of rotation pretty much. And the magnitude can be found by 360 degrees divided by your order number. So you'll notice this line of regular shapes that we have. We've got our triangle, our square, pentagon, hexagon, octagon, nonagon, and decagon. And their order is literally 3, 4, 5, 6, 7, 8, 9, and 10. Now, that magnitude can be figured out by doing 360 degrees divided by that order number. So for the triangle, same as our example from above, it's going to have that rotational symmetry. And the order of symmetry helps us to determine that it's going to be 60 degrees of that angle that we're rotating it at, because it's 360 divided by 3. That square is going to be 90 and so forth. You guys can do the math. We're also going to do a little bit extra on these 3D shapes here. Now, plane symmetry is if the figure can be mapped onto itself by a reflection in a plane. So you remember with line symmetry, we were just reflecting in a two-dimensional area. Now, plane symmetry is three-dimensional, and it's being split or reflected over a plane instead of a line. Axis symmetry is if the figure can be mapped onto itself by a rotation between 0 and 360 degrees, and that's on a line called the axis of symmetry. This is a three-dimensional version of rotational symmetry. You're splitting it and you're rotating an entire 3D figure and shape. So your job is now to tell me whether the figure that's shown here, this three-dimensional plus sign, has plane symmetry, axis symmetry, both, or neither. Now this one has both plane symmetry and axis symmetry. Now the reason is that I can go ahead and rotate this for axis symmetry, rotate it, and still get that same shape. And I rotated it 4 times, that order, magnitude, 360 divided by that 4 gets you 90 degrees, so that's my axis of symmetry. My plane, I can cut through the middle here, cut through this here, cut through the diagonals right there, but I can also cut through that middle, almost as if I'm chopping that top layer off, kind of like a cake. So this actually has 5 different ways that it has plane symmetry. All right, thanks for watching.